This video is on Cramer's rule to solve systems of equations. Now you can look up um, the way to solve them in the textbook. What I would like to tell you is a quick way to actually remember these determinants. So here's the idea. If we have 2 by 2, the determinants are fairly simple. Now let me sort of walk you guys through. Notice in the equation we have right here is a1 and a2 are coefficients of x for two equations, b1 and b2 are coefficients for y, and c1 and c2 are solutions. So if we quickly scroll down, notice x is actually defined in terms of determinants, dx over d. Y is dy over d. So what are these three determinants that we need to keep in mind? Well, D is actually the matrix of coefficients. That's an important one to check first because if it's 0, then we cannot use the Cramer's rule, and it's actually going to happen that the system actually has infinitely many solutions or no solution. Now dx, the idea is because it's dx, instead of the x coefficients a1 and a2, typically we replace the column by the solutions c1 and c2. Now notice that the y coefficients are actually in the same place, b1 and b2. So we go in the same order. Instead of a1 and a2, we replace them by the solutions c1 and c2. And notice dy, same idea applies. We keep the x coefficients in place, but instead of the y coefficients, we have the solutions there. So that's how we get the three determinants to keep in mind. And the same idea works with 3 by 3 when it's a lot more to remember. So notice here, if we have the Cramer's rule, notice that we check the determinant of the coefficients first, which is not 0, that's -1, that's a good thing. Notice we compute the dx, which is, again, we place the solutions first, and then we keep the coefficients of y, and it happens to be -1. We compute dy similarly. We have the coefficients of x in place, but instead of coefficients of y, we have the solutions. So we have -2. So x and y are simply ratio. X is dx over d, which gives you 1, and y is dy over d, which gives you 2. And here is a solution which we can write as an ordered pair, 1, 2. And that's the idea. Now I give an example where the d is 0, which I think is the next example right here. If the d is 0, we cannot use Cramer's rule, but it could mean one of two things. It's either no solution or infinitely many solutions. Here we check. This one happens to be infinitely many solutions. So it's a dependent system, and if you guys recall, we have to solve for one of the variables. Typically we keep y as a free variable and we solve for x, or we can do whichever one's convenient. So we have to resort to a different method like elimination to solve that one. Here's the idea for 3 by 3 system. If we have a1, a2, a3 are the coefficients of x, b1, b2, b3 are coefficients of y, and so c's are for z, and the k's are the solutions. So here's the idea. It's x is dx over d, y is dy over d, and so on. Now A is the coefficients matrix. The same way applies. dx, notice again, instead of the a1, a2, a3, we have the solutions column. And then we keep the order in the same way for the b's and the c's. dy, notice we have the a's for the x. The y's are replaced by the solutions. And here we have the c's for the z. And the same way for the z, we have x and y in the same order, but instead of the c's, we have k's as the solution. And then we just have to compute the determinants, which you can look at the notes above. So we compute the determinants, and I do actually show you guys, walk you through them. And a lot of times when you divide at the end, to get them to cancel out. For example, a lot of them were 11, so x happened to be 1, y happened to be 1, and z happened to be 0. So here is the solution for the 3 by 3 Cramer's rule.